Hi guys, I am Muhammad Naji Abu. Welcome to my YouTube channel. In this video, we will be discussing on basic intuition behind the gradient descent algorithm. Okay. So we know that a gradient means it is actually a measure how the steepness of a slope or a line. That is what mean by the gradient. Okay. So consider a neural network model. Okay, you can draw it something like this. We have a neural network model, something like this. Here we will have an input that is called x, and we will have an output called y hat. Then inside neural network, which is basically consists of weight and the bias, right? And what we will do after that, we will calculate the cost function, right? That is what usually happens. We will calculate the cost function. So here we will be using a squared error, that is y minus y hat all square. So this is our cost function, and what we will do, we will calculate the cost function, then we will be updating the weights back, right? Here we will have a optimizer, then we will update this weight back to the neural network, right? So this is what usually happens. Now in gradient descent algorithm, there is a formula to update the weight, that is W is equal to W plus change in weight, and if it is bias, which is equal to bias plus change in bias. So here we can say that delta W, which is equal to minus eta, this is called the learning rate, into dou cost function divided by dou W dw. Then here we can also, similar to that, the bias can be set as cost function, change in cost function with respect to the bias. So this is the basic formula of a gradient descent algorithm, the weight updation formula. Okay. Now we can take some assumptions. Okay. We can have some assumptions. First, consider first assumption as B is equal to, okay. So before that, we know that here, what is y cap? We have y cap, right? The y cap is phi into W x plus B, right? So in that case, the optimization function, that is y minus y hat all square, which is equal to y minus phi of W x plus B square, right? So this is the final, expanded cost function. So here, based on this formula, okay, based on this formula, we can take some assumptions. One is we can make bias as 0 to make the calculations easy. Okay, then consider y. We know that y is a constant, right? So we can make it as a constant k, and this can be assigned as a, consider as a 1. Okay. Now the third assumption is we know that phi of Wx, right? This is also give us a float number. Okay. So here this can be, we can represent it as a W. Okay. So the final equation will be, we can say that the cost function will be, we can say it as, or error function will be 1 minus W whole square. This is our cost function. Now we need to update the weight, right? So the weight form updation formula, let me write it again here. W, which is equal to W plus delta W. And here we can see that delta W is equal to minus learning rate into dC by dW, or dou C by dou W. This is our formula. So we have to calculate the dC by dW. So here we need to calculate dC by dW, which is equal to, we can calculate this as, first we can expand this function, right? This actually notation is not d, it is a dou. We can write it as, okay, for the time being, let it be like that. Dou W, we can say that 1 minus W all square. Okay. Now we can solve this. We can say that this will be 2 into 1 minus W into then into minus 1. So this will be we can say that 2 minus 2W into minus 1. This is equal to 2W minus 2, which is equal to 2W minus 1. Okay, so this is our dou C by dou W. Okay, now what we can do, we can take our first function, that is f of what we call W, which is equal to, we can say it as 1 minus W all square, right? So here what we can do, we can try to give some sample points here. Okay. Consider W is equal to 1. Consider W is equal to 1. W is equal to 1. So in that case, this will be 1 minus 1 all square, and which will is equal to 0. Now consider W is equal to 2. So here this will be 1 minus 2 all square, which is equal to minus 1 square is equal to 1. Okay. Now W is equal to 3. W is equal to 3. Here this will be 1 minus 3 all square, which is equal to minus 2 all square, which is equal to 4. Now consider W is equal to minus 1. So this will be 1 minus 1 all square. Okay. This is equal to 2 square, and which is equal to 4. And if it is W is equal to 2, we can say that this will be 1 minus 2. This is actually minus 2 all square, which is equal to 3 square, which is equal to 9. Okay. So this is our chart. Now what we can do, we can try to plot this in a graph. So for that, let me draw a line. Okay, here there is a line, and this line has to be, okay. Here this is W. Here we have 0. Here we have 1, 2, 3, minus 1, minus 2, minus 3, and this is f of W. So we know that when W is equal to 1, this will be 0. It will be here, right? Now W is equal to 2, the value will be 1. So let me plot here also. Here we can have 1, 2, 3, 4, 5, 6, 7, 8, here it is 9. Now here when 1 is equal to 2, sorry, when 1 is equal, w is equal to 1, then it is equal to 0, w is equal to 2, then this will be 1, then w is equal to 3, then this will be 4, somewhere here, right? Now when it is minus 1, this will be 4, and when it is minus 2, this will be around 9. Okay, so we can join these points. Can try to join these are not exactly correct, but we can try to join this, then we will get something like this. Okay, so this is a somewhat called a parabola shape. Now just consider our line is here. Okay, now we need to calculate the tangent of, we can draw a tangent of this line, and we can calculate the slope of this function. So that is, we already know that we have already calculated the cost function, derivative cost function, that is we have delta w. Okay, here we can say that minus eta into, can say c by dou w. We already calculated this portion, right? We know that this is, this we can say that dou c by dou w, we can say it as what we can say 2 into w minus 1. So that is a formula. Here we have 2 into w minus 1. So here w is equal to 3, right? So we can say that this will be equal to 2 into 3 minus 1, which is equal to 2 into 3 minus 1, 2, which is equal to 4. Okay, so this is giving a gradient ascent value. This is in the I direction. Okay, so to calculate the delta, what we need to, we have a formula w eta into 4. Okay. For the time being, consider the learning rate as 1. So the change will be, the delta w will be 4. Okay, sorry, this will be minus 4. So what will be our new weight? The new weight will be w is equal to w minus 4, and which is equal to 3 minus 4, which is equal to minus 1. So the weight is reduced, right? From 3 to, it reduced to minus 1. Okay, so just check the graph. So initially the point was here, then after the weight update, this will be come to minus 1. Here, this point, right? So there will be a sudden change from 3 to minus 1, right? Okay, so ideally what should happen? Ideally it should be traveling to these positions. Okay, these positions like this, and finally it has to reach the minimum value 1. Okay, so that is why we have introduced this value called eta. Okay, so consider the learning rate as maybe a small learning rate as 0.1. Okay, so in that case, what will be the delta w? It will be minus into 0.1 into 4. So this will be minus 0.4, right? So now calculate the w. So w will be w minus 0.4, and which will be equal to 3 minus 0.4, and which is equal to 2.6. So our new weight will be from here, from this 3, it has moved to somewhere here, 2.6, right? So in this way, the learning rate using the learning rate, we can control this particular action. Okay, instead of just going to like from here to kind of a zigzag motion, something like this will be controlled. I mean, the weight update will be controlled, and this will be slowly moved to the minimum value 1. Okay. So that is the main purpose of introducing the learning rate eta. Okay. So yeah, so that is all about in this video. So in this video, let me summarize here. In this video, we have, okay, sorry. In this video, we have done the optimizer, the gradient descent optimizer, and we have found the formula for gradient descent, that is W is equal to W plus delta W. Then we have calculated the delta W. Okay, so we have calculated the delta W by using some assumptions. So we made these assumptions to make the formula very simple and understandable. Okay, so we set its bias as 0, and we set its y is equal to as a constant value, right? And we have considered phi of Wx as a single constant value as W. Then we have applied different values for weight 1, 2, 3, minus 1, minus 2, and we have got, okay, we have got a parabola shape. Then we try to calculate the slope of this particular point. Okay, when W is equal to 3, we calculate the slope and we updated the weight. So we found that the new weight will be -1, and this is a drastic change from 3, right? So to control this kind of a drastic change, we have introduced a new term that is called eta. That is a learning rate which will control the weight update. Okay, the same thing can be applied to bias also. So I believe the concept is very clear. So in coming videos, we can discuss more about this. So please don't forget to like and subscribe.